Hey everyone, welcome to your first day of new content for our class. So we're going to start off with chapter 11, which is titled Introduction to Organic Chemistry, Hydrocarbons. So we'll also call these alkanes, as you guys will learn in the next few videos. So this PowerPoint or this set of notes is going to cover for class today and then on the next lecture period on Friday. And I've listed out what chapters in the book this is, or sections in the book this is, and some practice problems for you guys to try out these concepts. So the first question really is, why are we studying organic chemistry? We've talked a little bit about it in different introductions and everything, but organic chemistry, which is the study of molecules containing carbon atoms, provides a foundation for our understanding of complex molecules of biology. So it makes, or biochemistry, thank you, sorry. It makes it so that we can understand the molecules that make up our bodies or living things. And organic chemistry or organic compounds are compounds that are in your body or in living systems or really anywhere in your life, but we're going to study kind of the smaller side of things. So small molecules. As I just said, organic chemistry is part of our everyday lives. In examples such as gasoline. So our car uses octane gasoline in order to provide energy for the car to move. That is an organic molecule we'll talk about today, actually. We have medicines, which is one of the most traditional ways that organic chemists are viewed is for their work with medicines. So traditionally, medicines are small molecules that interact with your cells in your bodies or interact with the proteins in your body in a very specific way to either block something or change something about how the molecules in your body are made. Shampoo is an organic molecule. Hopefully all of you use at least once or twice a week. It has different kinds of properties to it. So a hydrophobic and a hydrophilic end, meaning that's how soaps work. So there's one part that gets rid of oils and greasy stuff and one part that attracts ionic compounds or more kind of dirt type compounds. So that's how it cleans your hair. We also have cooking oil. So the oil you put on your pan, that's any kind of oil is a organic molecule. And then lastly, things that we all touch every day, plastics are organic molecules as well, or organic polymers to be exact. So organic chemistry allows you to study the chemical reactions that allow for life. So as an organic organic chemist, that is what I do every day. I do chemical reactions to make new things, and I specifically study making a brand new chemical reaction that nobody else has ever done before. As you'll notice, coming up soon, we draw a lot of shapes, specifically hexagons are the most common. So this is my little picture just describing that. I feel when I took organic chemistry, I think that's how I felt, is it was a hexagon drawing class. And then the last one, I have no idea what I'm doing. This is me all the time. If you ask any of my coworkers, this is like all of us all of the time. And that's why we do research, is because we don't know. The last thing for this particular video, we're going to be looking at what are organic compounds. So some properties of organic compounds are that they contain one or more carbon atoms. And in addition to those carbon atoms, they have many hydrogen atoms as well. 99.5% of all of your atoms in your body are made up of carbon, hydrogen, nitrogen, and oxygen. So those are the 4 essential atoms to life, not just our life, but life in general. And then organic compounds can also contain things like sulfur, phosphorus, or halogens, which we show as X. That's just kind of the general letter that we use for that. So any of the halogens, you just show it as X so that you're talking about all of them or any of them. So comparing and contrasting organic and inorganic molecules, the first thing we're going to look at is what kinds of things are in them. So organic molecules are carbons, hydrogens, nitrogens, oxygens, sulfurs, phosphorus, and halogens. And then inorganic molecules are more traditionally metals and nonmetals. So what kind of bonds do these things have? Organic molecules are typically covalent, and inorganic molecules are typically ionic. So covalent, remember, is the sharing of the electrons in between them. So we draw that as a line. And ionic bonds are more like a positive charge that's attracted to a negative charge. Melting points and boiling points. Typically, organic molecules have low melting points and boiling points, whereas inorganic has high. The next line here is talking about how flammable it is. So organic molecules are very flammable. Obviously, given their properties, some are not as flammable, but we typically see that they are flammable. And inorganic molecules are typically not flammable. And then the last one is the solubility in water. So organic molecules are generally insoluble in water, meaning that they do not mix with water very well. Think about, I just said oil or cooking oil is a organic compound, a traditional one. And when you mix oil and water, or oil and vinegar, let's say, vinegar is water-based, you see those two layers, they don't mix together. And then inorganic compounds are generally the opposite, they're soluble in water. So some examples of molecules for each of these. Propane is a really good example of an organic molecule. It's C3H8 right here. This is used in propane torches, so it combusts and forms heat and light in the shape of fire. And just to show those melting points and boiling points, the melting point of propane, so from solid to liquid, is negative 188 degrees Celsius, super cold. And then the boiling point is negative 42, so liquid to gas. So that means that at room temperature, propane is always going to be a gas. On the contrast, sodium chloride, or table salt, is an inorganic molecule that we see pretty much every single day, depending on how well you salt your foods, I guess. And you can see that its melting point is not until 801 degrees Celsius. So there's less atoms in it. There's only 2 atoms, whereas the other one, propane, has 11 atoms? Many less atoms, but its melting point is so much bigger. Its boiling point is 1400 degrees, so much higher. So it really shows off the properties of the different kinds of molecules that we're looking at here. Well, this is our first intro into organic molecules. I will see you guys in the next video.